What's up everyone? Welcome back. I'm Nick. This channel is Swiftful Thinking, where we cover all things Swift and SwiftUI related. And in this exciting video, we're going to look at weak self. We're going to learn what exactly weak self means and why we use it. And I'm super excited to share this because this is something that I wish someone had stressed and explained to me more when I was learning app development. It's often overlooked as people start to learn app development, and a lot of beginner courses don't even touch on it, but it is very important. In order to get into weak self, we first have to understand automatic reference counting. And you can Google this, ARC, automatic reference counting, and Apple probably has a bunch of articles on exactly what it is. But basically, every time you make an object or a screen, the system is holding a reference to that object. So reference counting by itself is pretty simple, but as developers, we want to keep this count as low as possible because it makes our app more efficient and faster. And oftentimes in your app, when users are moving around the app, behind the scenes, the app is actually deinitializing screens and views that the user is no longer using. So this is efficient. So if they go to the screen and then press it back, that screen might get deinitialized. So any objects that were created on that screen would then be removed from our count. And this is great, but sometimes in our app, we end up writing code that doesn't allow that screen to deinitialize when we actually want it to. And you might not even realize you're doing this, but you basically are creating a strong reference to that screen or that object. And the solution is to basically create a weak reference instead of a strong reference. And that's kind of what weak self is. Now I'm covering it right now because in the next bunch of videos, we're going to start downloading data from the internet. Because when we have these functions that are going to the internet and then coming back, it becomes super important to understand these strong and weak references. And you're probably going to want to use a weak self a lot of times. So I hope this doesn't get too confusing for some of you guys. Leave a comment below if you are still confused. But I think the example we're going to go through really helps to explain it. Alright, and if you are enjoying this content, please don't forget to hit the like button and the subscribe button to stay up to date with all of these videos and this playlist. Alright, welcome back everyone. I'm back in Xcode as always. In this video we're looking at the weak self call, and we're going to do that in a new file. So let's right click on the navigator, create a new file. It's going to be a SwiftUI view, and let's call this weak self bootcamp. Go ahead and click create. Once you're inside, click resume on the canvas. And this again is something that I wish someone had talked to me a little more about when I was learning to code, because this is very important when you actually make applications. And I don't think a lot of beginners even think about something like this. So some of what we're doing here is a little bit abstract, so I try to find the simplest way to explain this to you guys. And what we're going to do is create a navigation view on our screen. We'll add a navigation view, open the brackets. Inside the navigation view is going to be a very simple navigation link. Open the parentheses. We're going to use the, let's use the string protocol and destination. The title will say maybe navigate. Nothing important here. And then the destination we're going to change in a second. But let's just make it a text right now with a blank string. And let's create a second screen here. So underneath this struct, I'm going to create a new struct. Let's call it weak self second screen. It will conform to view, just like our main view. And every view needs a body, and we'll open the brackets. The body here is going to be very simple. It's just going to be a text that says second view. Let's give it a font of large title and a foreground color of red. Let's add this into our destination. So we'll do weak self second screen. Let's click resume on the canvas just to make sure it all works. Let's also add a navigation title here, screen 1. Alright, so we're on screen 1. We can press play here on the canvas, click navigate, and it should bring us to the second view. Alright, so this is a very simple app. If you're confused at this point, you should probably go check out some more beginner videos on my YouTube channel, because this should not be anything new to you guys. This should be very simple. We have two screens in a navigation view. We can navigate, we can press back, and here we are. All right, this second screen is going to have a view model. So we're going to create that now. We'll do it underneath this struct. We'll say class, let's call it week self second screen view model. I know it's really long to type here. The name doesn't really matter. Let's make it conform to observable object as always. Open the brackets, and we're going to create a @published in here. This will be a var, we'll call it data, and it'll be of type string. We're going to make it optional with a question mark. We're going to set it equal to nil for now. Inside this view model, we're then going to create an init, open and close parentheses, open the brackets. In this init, let's print out initialize now. And we're going to call a function to get data. So let's create a func get data, open close parentheses, open the brackets. From in the init, we'll call get data. So as soon as it loads. And in get data, we're just going to call data equals new data. Before we leave here, let's also create a dinit, which is pretty much the opposite of an init. This happens when the screen gets initialized. This happens when the screen gets deinitialized. And let's just print here. We'll print deinitialize now. All right. The last thing I actually want to do is put this data, this string, onto the second screen. So on the second screen, let's first add the view model. We'll do an @state object var vm for view model equals the week self second screen view model. And let's hold the command button, click on this text. Let's embed it in a VStack. And below the second view text, we'll say if let data equals vm.data, open the brackets. So if this is data, so if this is actually a value and not equal to nil, we'll then add a text here and we'll put in the data. All right, if I click resume on the canvas, let's first check that this data is loading in. Let's click navigate and it says new data, perfect. And now let's run this on a simulator. So I'm going to take this. So I'm going to take the first screen here, which is our week self bootcamp. I'm going to jump into our app.swift file. I'm going to make this the first file in our app. Make sure we're on an iPhone 12. You could do it on whatever simulator you would like. I'm going to do an iPhone 12. And let's run it on a simulator. I'm going to jump back into our file here as well. I'm going to close the canvas. And you can ignore some of these warnings that are coming through right now. It's just some Swift UI stuff that Apple's probably working to get rid of. And I'm gonna actually just scroll down here and let's press enter a bunch of times to break this out. But when I click navigate, it should initialize a view model. So let's click navigate, initialize now. I'm gonna go back and I'm gonna press navigate one more time. And when we clicked it the second time, it initialized the new one and deinitialized the first one. And I'm going to press back and forward and back and forward. And you can see here, every time we go to this screen, it is deinitializing one and initializing a new one. Okay? So let's create a quick little variable on our screen just to track how many are initialized at a time. So we're going to do a quick kind of little hack here. We're just going to create a user default. So on our first screen here, let's do it on top of the navigation view. So at the bottom of the navigation view, I'm going to add in .overlay. And let's add a text. Put the number 1 for a second. Let's see if we see it. Let's go to background of color.green. Sorry, let's open up the canvas so we can see what we're doing. Alright, we can see our number here. Let's give it a font of large title. Let's add some padding. And let's give this overlay we'll use the comma and we'll add alignment of maybe top trailing. Just so it's on the top right here at all times. Let's give that background a corner radius 10. Alright, so this is how many are initialized right now. So this number 1, let's make it track in a user default. And I covered user defaults in another video, so I'm not going to go over how they work. In this one, you can check out my other videos on app storage. But let's create an app storage. We're going to use a key here, and this will be, let's just call it count. This will be a var, and we'll call it count. And this will be of type int, and it will be optional in case it's not set yet. And we're just going to put this count into the text here. So we'll do a \, open close parentheses, put the count, and because it's optional, if there is none, let's do 2 question marks and have it be 0. If I click resume, it should work. We got 0. And now every time we initialize, very simply, let's first get the current count. So we'll say let current count equals user defaults dot standard dot integer for key, and the key is count. Remember, this key is the same as the key that we just did up here. And remember, we're using user defaults down here because we are not in a view, but because we're in a view, we can use app storage up here. I covered this all in the app storage video, so I'm not going to cover that again right now. But this should be the current count, and then we're just going to set user defaults dot standard dot set, and we're going to look for the integer, and we're going to set current count plus 1, and this will of course be for key count. And when we go to deinitialize, let's copy these 2 lines, and we're just going to do -1 on the deinitialize. Okay, so every time we initialize, we add 1. Every time we deinitialize, we'll -1. So these should be equaling each other out. And the last thing I want to do here is actually on that first view, every time we load the app, let's just start the count back at 0. So we'll do init, and here we'll just set the count equal to 0. All right, let's run the app on a simulator quick. Our count is 0, and when I go to navigate, count goes up to 1. And if I go back, we can see our prints are coming through, our initialize now. If I go to do another one, we initialize the new one, but we also deinitialize the old one. So the count is still 1. If I go back and I go forward and I go back and I go forward, I can do this a whole bunch of times, and the count is always 1. So this is great, and this is efficient, right? Because if this count kept going up, it would be saving the memory of all of those old screens. But right now our count remains at 1, and this is perfect. The problem comes into play here when you are running asynchronous tasks. So right now this is just happening immediately when we call get data, and everything is working fine and we're all happy. So if you watched my last video, we were going on the background thread, we were using a dispatch queue.global.async. And when we put our call into that call, we got this error message that the reference to data required explicit of self. And to fix it, we went self period. And this was creating a strong reference to this class. And when you're doing this, creating a strong reference, basically what you're telling the system is that while these tasks are running, this self, so this class, absolutely needs to stay alive because we need that self when we come back. And right now this is a very quick task, so it wouldn't actually be a problem. But if you were downloading like a lot of data from the internet, the code in this async task might take a couple seconds. It could take like 10 seconds. And during that time, the user could be doing something on the app, like maybe pressing the back button. And by the time the call comes back, you might not actually need this self to be alive because maybe the user's already gone, they're on a different screen, they don't need this data anymore. So to simulate a very long task, we're going to use dispatch queue.main.async after. This just creates a delay, and we'll do .now plus, let's do something absurd like maybe 500 seconds. And then we're going to press enter on here, and we're going to take our code and put it in here. We're going to get rid of this first call. And basically what we're simulating here is a very long background task. So this task will take 500 seconds. That's a very long time, and when you're downloading data from the internet, it's not going to take 500 seconds, but it will take some time, and that's kind of what we're simulating with this line of code here. So after 500 seconds, the data should then update. So let's click play on the simulator one more time. We're at 0. Let's navigate to that second screen, and it goes to 1, so we're looking good. And now we're going to go back, and when we go to navigate again, it goes to 2. We haven't seen it go to 2 before. And if we look at our printouts, the initialize was called twice, but deinitialize was never called. And the reason the deinitialize was never called is because we had this strong reference to self here. And when we had this strong reference to self, we told the code that that class could not be deinitialized until this closure completes. So after this 500 seconds, this will then be complete, and then it will deinitialize. But until this 500 second completes, this self will always stay alive in our code. So for some things that could be good if we absolutely needed this line of code to happen. But a lot of times in your app, like what we just did, within that time frame, that 500 seconds, the user navigated away. They went to another screen. And so once they did that, we didn't really need to update that original screen that they were on, right? Because they're gone, they've moved on, they're doing other things in the app. So the fact that we keep this alive is actually not efficient. And we can see here that if I keep on navigating back and forth, our count is going to keep going up because we're creating all these strong references. And what's happening behind the scenes here, in the second view, we're creating these view models. And right now there are 8 of these view models alive in the background of our app. And the fact that we're only on the screen here on one of them just proves that this is not efficient, because we now have 8 classes in the background and we only really need one, right? We only need the one that we're on right now. We're never going to get back to that old screen. So you could imagine that if you created these strong references all around your application when you're using this self dot, you're going to get a ton of objects all around your app that are alive that don't need to be alive. And when you have all this extra stuff in your app, it is just going to basically weigh down the app, and it could slow things down. So as the developer, this is very important because this could definitely slow down your app. So the solution here is basically, instead of calling self with this strong reference, which means we absolutely need this class to stay alive, we could instead add a square bracket and say weak self, and then add the word in. And this weak self basically just makes this self, instead of being a strong reference, it turns into a weak reference. And we're going to get a quick error message here that it is now optional. So we can fix it with the question mark. And basically this code is the exact same as we had, except self is now optional. So we still have reference to this data that we can update, but we're telling the code here that we don't absolutely need this class to stay alive. So if this class, for whatever reason, gets deinitialized, it's okay. And we can just ignore whatever these calls are. So if I run my app one more time, and I start clicking forward and back, you'll see that the number stays at 1 again. Because even though this call didn't come back, this reference to self was weak. It wasn't strong, so because it was weak, we allowed it to deinitialize. And we got our deinitialize calls back here. So generally speaking, in your app, when you have these long tasks that you're like downloading data for the user, it's very important to add this weak self. Because if you're downloading data for the second screen and then the user goes away to another screen, you don't really need that first screen to stay alive anymore. And if you kept that screen alive, it would stay in the memory, it would start to slow down your application, and it just wouldn't be very efficient. Alright guys, I hope that wasn't too confusing. Basically the bottom line here is, by using weak self, we can make references to classes and to self optional, so that we're telling Xcode it's okay if this class deinitializes, because if we have a strong reference, it's telling Xcode that we absolutely need the class to stay alive. And in that scenario, you would run into situations where this number keeps going up, And you can imagine in your app, if you had tons of calls all over your app and all these extra classes and objects were staying in the memory, it could definitely weigh down your app and slow things down. So to be professional, efficient, expert developers, we use weak self a lot of the times when we're doing things that are asynchronous tasks, such as downloading data from the internet. Alright guys, I hope you enjoyed this video. As always, I'm Nick, this is Swiftful Thinking, and I'll see you in the next video.